Vector embeddings are the secret language of modern AI. They allow machines to understand words, images, and even music, not just as raw data, but as rich, meaningful concepts. In this video, we're exploring how vector representations power technologies like ChatGPT, image generation tools, and even recommendation systems. Let's start with the basics. A vector is just a list of numbers, but in machine learning, a vector becomes a way to represent meaning. Instead of working with raw words or images, AI systems convert that data into numerical vectors. These vectors live in something called high-dimensional space, a place where complex relationships can be understood geometrically. For example, in word embeddings, the words king, queen, man, and woman are arranged in such a way that king, man plus woman is very close to queen. That's the magic of vectors. There are different ways to turn data into vectors. 1. Hot encoding is a simple method, but it doesn't capture relationships between data points. TF-IDF improves on this by considering how important a word is in a document. Word, to, vec, and glove go even further by learning the meaning of words based on context. These techniques laid the groundwork for modern AI systems. Today's large language models, like GPT and BERT, take embeddings to the next level. They don't just represent single words, they use contextual embeddings, meaning each word's vector changes depending on the words around it. This helps models better understand nuance, tone, and intent. Embeddings are also used in training generative models like VAEs and GANs, where data is mapped into a latent space, an abstract, compressed version of reality. The problem? These vectors often exist in hundreds or even thousands of dimensions. That's hard for us, and sometimes even for computers, to work with. That's where dimensionality reduction techniques come in. PCA simplifies data while keeping the most important patterns. TSNE and UMAP help visualize complex data sets by compressing them into 2D or 3D. These tools help researchers and engineers better understand how AI is thinking. Vector embeddings are everywhere. Search engines use them to match queries with relevant content. Recommendation systems like Netflix and Spotify use them to suggest what you'll love next. Text generation, image synthesis, and even music creation all rely on embeddings to generate content that feels human-made. In business, embeddings are used to analyze documents, detect fraud, and even power virtual assistants. But embeddings aren't perfect. They can reflect and even amplify bias present in the data. That's why it's critical to monitor and test these models, especially when used in sensitive areas like hiring or law. Looking ahead, we'll see more advanced embeddings across multimodal AI, combining text, images, and audio in ways we've only started to explore. Vector embeddings are more than just math. They're the bridge between raw data and real understanding, helping machines speak our language, create art, and assist with everyday tasks. If you found this valuable, don't forget to like, share, subscribe, and hit the bell icon so you never miss an update from Anasup Consulting.